Okay, good morning everyone. My name is also Anat Stanley and my metric number is 05DGU20F1001. Okay, for today I want to describe about difference between the automation concept using total station and GNSS. Okay, firstly, I want to explain about procedure using total station first. Okay, let's see. Okay, first step you need to know is set the instrument up over the station mark 2 and set the prism up over the station mark 1. After that, using the automation concept, you need to fill the information required to be stored in the total station memory, such as instrument height, reflector height, mini prism height, coordinate of datum if have. Okay, and the last one is bearing and distance of datum. Okay, after you fill the information in total station memory, thirdly you need to select a nearby control station as a reference object or cite this point and record the horizontal circle reading. Okay. After that, all the detail in the radiation pattern will now be fixed in relation to this chosen direction. Okay. Fourthly, the mini prism mount on the detail pole in here at the detail point being fixed and observed by the total station. Okay, care should be taken to ensure that the detail pole is held vertically. Okay. Next step is the actual observations taken at each pointing are being recorded. Care should be taken to stand by a backup of traverse booking and the sketch of the record detail. Okay. And next step is once point P has been located, the detail pole in move to the next point and the procedure is repeat for each detail point in turn until all observations have been complete. Okay. As far as is practicable, each of the detail points should be selected in a clockwise. Okay. The final setting should be back to the RO to check that the setting of the horizontal circle has not been altered during observation. Hence, it is advisable during a long series of total station readings to take a sighting of back to the RO. Okay, using automation survey concept, all measurement recorded must be downloaded from total station to computer using cable, Bluetooth, Wi-Fi, memory card, or USB. And final step is the data can be processed using survey software such as Civil Design and Survey CDS. Okay. Okay, procedure using GNSS. Okay, firstly, locate the benchmark monuments or landmark to be measured. Alternatively, establish a new monuments. Second, whenever you establish a camping monument, it is absolutely essential to thoroughly record a monument log. Thirdly, set up the tripod spike mount on another mark on top of the benchmark. See the GNSS antenna mount guide. Okay. Fourthly, center tripod over the benchmark and level the antenna mount. Okay. After that, actual legs so they will not move throughout the survey. Okay, attach antenna to the top of the mounting system. Okay, next step is connect all appropriate cables. Okay, the antenna will connect to the receiver with the battery being connected last. Connect the battery last to avoid unrecognized equipment. Step 8. Measure and record slant height or antenna height to base center as appropriate. Okay. To measure slant height, place measuring stick or tape on center of benchmark and measure to the outer edge of the antenna where base center is located, as found in manuals. And step 10 is measure in at least three locations around antenna. Measurements should be equal if the tripod is level plus or minus 0.5 centimeter. If not, we level system before recording data. Do not move the tripod after labeling is completed or while data is being collected. Doing so will affect the precision of positioning. And finally, record general site observations, location, times, and configuration in a fair book.
Hello everyone, my name is Lau Miu Ying. Norm matrix is 05DGU20F1005. Today, I will present the data qualities between GNSS and total station. The data qualities is measured by two instruments. One is a total station and the other is global navigation satellite system. Total station is an electronic and optical instrument used for surveying and building construction. GNSS is a satellite system that is used to pinpoint geographic location of a user's receiver anywhere on land and seas, in the air or in Earth orbit. GNSS have higher qualities and more accurate data than total station. The data obtained by GNSS is even higher because GNSS is measured by technology. The data obtained will not have large error. Compared with the data obtained by GNSS, the total station is lower. Since the total station is manually operated for measurements, if the operation of measurement is inaccurate, it will cause a large error in the data. Once the measurement is inaccurate, the obtained data is also wrong, so the measurements must be repeated until the data is accurate, which will waste a lot of time. Generally speaking, GNSS is more accurate than the qualities of the data obtained by the total station. Thank you.
A total station is an electronic and optical tool used in construction and surveying. It's an electronic transit to the light with electric distance measurement (EDM) for measuring vertical and horizontal angles, as well as the slope distance from the measurement to a specific point, and an on-board computer for data collection and triangulation calculations. There are dominant instruments in measurement such as tripod, prism, mini prism, and prism poles. The main qualities are unsurpassed measuring range, speed, and accuracy. Total stations are designed with the user maximum convenience in mind. Electronic tachometers with high efficiency have been developed for decision making. For the sole purpose of industrial difficulties, it has a largely ready shape. The advantage of this technology over GNSS equipment is the speed with with which field operation may be complete. Furthermore, measurement precision is good. Computers may be used to create maps and generate contour and cross-section plots. Field data collector files are downloaded to an Office PC platform where the file data can be edited and modified so it can be directly input into a CAD or GIS software package for subsequent design and analysis use.
Next, GNSS is a satellite system that is used to pinpoint geographic location of a user's receiver anywhere on land and sea or in the air or Earth orbit. There are two methods in collecting topography data, which is using kinematic and RTK survey that are totally different concepts from the total station. By using less equipment and labor but need a proper skill to handle the instruments. A kinematic GNSS survey can provide a rapid means of collecting widely distributed high-precision topographic data. The advantages of this technique over an optical instrument such as a total station are that it only requires one person to operate and it does not rely on maintaining a direct line of sight. Through a field-based application of kinematic GNSS, it will design and conduct a topographic survey and interpolate collected points to create a continuous elevation field. The data collected by the roving receiver is stored in collectors or on-board receiver, then transferred to a host computer after the fieldwork has been complete, and the host computer will use specialized software depends on the hardware, such as CAD, to produce engineering plans.
Hello, my name is Winnie Tan Siu Ching. Node matrix is 05DGU20F1004. Today, I want to share about the difference between of costing in the concept of automation in collecting topography data using instruments, total station, and global navigation satellite system (GNSS). The cost of the total station is about 20,000 to 60,000, whereas the cost of the GNSS is about 12,000 to 30,000 that is searching on the online. When using instrument total station to collect the topography data, other equipment is also need to assist in the measurements such as prism. Cost of other equipment is around the 2,000. Furthermore, GNSS is also need other equipment for measurements such as tripod. Cost of other equipment is around the 1,000. So it can be seen that using total station to collect the topography data is more expensive than the GNSS. That's all for me. Thank you.
Today, I will explain about the final product. The first picture is total station, and the second picture is Global Navigation Satellite Systems, or we call as GNSS. Total station. Components of a total station. Total station is a compact instrument which weighs around 50 Newton to 55 Newton. It consists of a distance measurement instrument, or we call it EDM, an angle measuring instrument, which is theodolite, and a simple microprocessor. The components used in total station surveying are as follows. 1. A tripod is used to hold the total station. 2. an electronic notebook used to record, calculate, and even manipulate the field data. 3. Prism and prism pool, which can measure lengths up to 2 km and up to 6 to 7 km, can be measured with triple prism. Number 4 is a battery. Currently, there are approximately more than 40 different models available. Total stations are currently the most used instrument in the surveying field. Cheapest instrument is available in the range of $2,000 to $2,500. Leica is one of the most famous total station manufacturers. The advantages of total station. The first and foremost advantage of using a total station is that it saves time of work on the field. It understands and supports all the local languages. Setting up of the instrument on the tripod can be done easily and quickly by laser plummet. The accuracy of measurements is much higher in comparison to other conventional surveying instruments. Computerization Computerization of all maps can be achieved by total station. The computed data can be saved and simultaneously transferred to the computer. No writing or recording errors can be detected since everything is computerized with the help of data accumulated from total station. Map making and contour plotting can also be done. Correction for temperature and pressure can also be made. While the advantages of total station, the working conditions of the total station should be checked beforehand by the surveyor before using it. The cost price of the instrument is higher than the other surveying instruments. Checking for errors or other things during the operation is slightly difficult for the surveyor. Essentially, skilled surveyors are required to handle it since it is a sophisticated instrument error. Global Navigation Satellite System, or we call it as GNSS. Global Navigation Satellite System refer to a constellation of satellites providing signals from space that transmit positioning and timing data to GNSS receivers. The receivers then use this data to determine location. By definition, GNSS provides global coverage. Examples of GNSS include Europe's Galileo, the USS Navstar's Global Positioning System (GPS), Russia's Global Navigationnaya, Sputnikovaya Sistema (GLONASS), and China's Beidou Navigation Satellite System. The performance of GNSS is assessed using four criteria. 1. Accuracy. The difference between a receiver measure and real position, speed or time. Number 2. Integrity. A system's capacity to provide a threshold of confidence and it in the event of an anomaly in the positioning data, an alarm. Number 3. Continuity. A system's ability to function without interruption. And number 4 is availability, the percentage of time a signal fulfills the above accuracy, integrity, and continuity criteria. The advantages of GNSS is are it saves time and money by delivering increased location accuracy and enhanced performance. Then multiple GNSS systems offer uninterrupted connectivity in all the locations such as dense and vast forests, densely populated city. Number 3 is GNSS receivers remove any failed satellites from its list of navigation solution automatically. And the disadvantages of GNSS is it cannot support requirements of all phases of flight with stringent precision approaches. Hence, augmentation systems are needed along with GNSS system. GNSS affect aircraft operators, aircraft services, pilots, and regulatory personnel. The safety of GNSS navigation depends on accuracy of navigation databases. That's all.